Good morning. The next speaker is Professor Hans Hansen, Head of Mechanical Engineering Department, Technical University of Denmark, President of CIRP.
Thank you very much. Thank you for the kind introduction. And welcome here from a sunny Copenhagen. I'm going to share with you some information about how we established some 10 years ago the Manufacturing Academy of Denmark. But before that, I'd like to have, let's say, a soft approach, telling you a bit about myself and a bit about the International Academy for Production Engineering. And also, I couldn't help putting in a few technical examples of some of the work we have been doing within the framework of Manufacturing Academy of Denmark. So yes, I was really nicely introduced by Marcella. So you might ask, what is micromanufacturing? And if you look at the left bottom picture of this screen, you see a hearing aid. This is a type of hearing aid which you put into your ear. And on those hearing aids, you have many small functionalities like small buttons. And the micromanufacturing could, for instance, be how do we actually design, produce, and make quality control of mechanical components which are quite tiny, below the millimeter in diameter. I have been taking up different roles at the Technical University of Denmark, currently the head of Department of Mechanical Engineering. And I have also been active in the International Academy of Production Engineering, CIRP, where I'm currently the president. And back in 2017, I was also the president of European Society for Precision Engineering. So you may know CIRP, and if you do, please apologize for a few slides. CIRP was founded back in 1951 by 5 professors from France, Belgium, Great Britain, and Switzerland in order to promote scientific understanding of production engineering technologies in general. And still today, CIRP is having a world-leading role in the field of production engineering to promote research and development among members coming both from academia and industry to contribute to the environmentally sustainable global prosperity and well-being of society. And CIRP is following that vision by entertaining research in the fields, in traditional fields of production engineering like machining, metal forming, machine tool design, performance, precision engineering, metrology, as well as surface technology, but also engineering design, optimization of production systems, as well as assembly and life cycle engineering. So I would urge you, if you don't know CIRP, to visit the website you see at the bottom of this screen to learn more, and hopefully we will be able to meet each other in the future within the framework of CIRP. So Denmark is a relatively small country that you may know. We are in the north of Europe. The Technical University is located near Copenhagen, which is the red dot here. And it's actually a quite old university. It was founded back in 1829 by Professor Ørsted, the discoverer of electromagnetism, but also of aluminium. And it was actually founded as a spin-out of Copenhagen University with the purpose at that time to develop and create value to benefit society by looking into natural sciences and technical sciences. And still today, this is the mission of our university, which means that, of course, we aim to do research at the highest level, but always with the intention to have the research results go into sort of work in society, in the companies around us. The Mechanical Engineering Department is structured into 6 sections you see here, of which Manufacturing Engineering is one, and of course that's where I'm going to focus my talk today. And I'm showing you these pictures because back in 1990s and year 2000 moving forward, if you talk to colleagues about what production engineering and manufacturing engineering was, these were the type of pictures that people would have on the back of their minds. So something manual, something old-fashioned, something very mechanical. And at that time, the intention, at least in the Danish society, was everything like this should be outsourced to somewhere else where we don't see it. The matter of fact is, of course, that modern production and modern manufacturing is far from that reality. And when people then are introduced to the reality as it is seen today, they get quite intrigued and interested in also pursuing research within the field of manufacturing. So traditionally, I may say that usually a lot of research and development within manufacturing is driven by automotive, aerospace, and defense sectors. And if you look at Denmark, we are not having any of these sectors. In fact, the production sector in Denmark is relatively different from what you see in big countries like Germany, France, or UK. We have very few very big companies, and then we have a huge amount of small and medium-sized enterprises working in areas like medical sector, food, energy, automation, and robotics. And for some of you that may know some Danish products, I have put some pictures here that you may recognize. So this is a background for discussing back in 2000 what is the situation of Danish manufacturing industry and level of competence in that industry. And on the basis of that, the Danish Industry Association, together with leading companies and universities in Denmark, proposed to start the Manufacturing Academy of Denmark, in short, MADE. At that time, outsourcing was the big animal in the discussion. If we could just outsource to low-wage countries all our manufacturing, then we would be, for the next many years, we would be in a good spot. But what also happened was that the companies, and the first realization came to the big companies, that by outsourcing production, also product development skills slowly but surely disappeared. And around 2010, the big companies sort of realized that something needed to be done if you wanted to maintain a leading position as a product developer and manufacturing company also in Denmark. So a political effort was made to set aside some money that could be applied for by a consortium, and this was done in 2013. I was one of the professors writing these proposals, and the organization was launched back in 2014. The vision of MADE is to create world-class production through a combination of research, relevant research for the companies, through a large amount of innovation activities where this research knowledge somehow is guided into the industrial companies, but also by educational activities. And I would say now, almost 10 years after we started, I think MADE has succeeded in the research and innovation part. We are still struggling to find out how that knowledge can also be turned into educational activities for professionals. But of course, at engineering schools and universities, in particular, the education of PhD candidates has, of course, been a success. So even though Denmark is not a big country measured by kilometers, there might be, let's say, cultural differences from east to west, from north to south. And one of the main success criteria was actually to be represented by companies and universities, educational institutions all around the country. And here you see a plot that should illustrate that. The curve here is slightly outdated. Back in 2018, around 160 companies. I'm sure today we are above 250. So quite a big success in terms of interest from the companies. Also, you can say that in the period from 2010 to 2020, the increased pressure on companies of all sizes due to the digitalization of manufacturing has become quite intense. So the pressure to change has been significant. Not only because competitors were pushing companies, but also because customers, so big companies, were putting a lot of pressure on their suppliers, the small and medium-sized companies, both in terms of components, but also in terms of technology. So this has, of course, helped move the attention towards also performing research. And so how do you get a very diverse group of companies actually to agree on anything? And that was the big question back in 2013, where I used a couple of months together with two colleagues to tour Denmark, to visit companies and hear what are your problems, and if we were to put into consideration a program to try to address these problems, how could that look? And so what you see here is a 3x3 matrix. The columns have titles, and these titles you could call focus areas. And after these 2 months of road trip, it was quite clear that most of the companies were interested in performing research that could help them to get product and production developed at a higher speed. Many of them were interested in how to use models in their planning, but also in their execution and optimization of their production. And quite a few were interested in either to lower complexity of their production systems in general, or being able to manage higher complexity than their competitors. So these 3 columns mark the industrial interests. And then as you see on the horizontal, you have 3 different levels. You have the technology level, where you look into specific technologies, specific machines. You have production system level, where you look more into the production systems, and then you have the value chain or business systems at the higher level. And this spans out 9 work packages or 9 focus areas of the program in MADE, where the companies would be able to find themselves. So if you were a company like the Danish company Grundfos, who makes pumps and pump solutions, they were focusing entirely on the first column of rapid product and production development. A company like Danfoss, making heating solutions and cooling solutions, were primarily interested in the hyper-flexible automation. And a company like Lego, producing toys, were primarily interested in enabling technologies. And in this way, the framework and the focus areas of single companies were then spread out to this. Then as time went by, 3-4 years, it was quite evident that digitalization took up speed, and therefore a digital layer was put on top of the original layer, of course still spanning the same 3x3 work packages, but now with a digital touch. And this then led to a new application, a new funding scheme, where digitalization was in focus. Still, the companies would have to be able to find themselves and their challenges within this scheme. And many of them actually moved from the first scheme to the second scheme in terms of where would their focus areas be, so that they would sort of broaden their field of interest after having seen how it worked in the first place. And so the working principle would be to start by identifying industrial challenges, to try to, based on that, define research activities, to run pilot projects in the companies who have been defining the industrial challenges, and then to take out, let's say, general learning points that could then be transferred to the big amount of small and medium-sized enterprises out there. And to give you an example on hyper-flexible automation, for instance, 3 industrial challenges were identified. So one challenge was related to how to automatically place carbon fiber mats for fiber reinforced plastic components. You see a picture here. Another one would be to make reconfigurable automatic meat packing, where you can say that the components or the products, they change component by component. And the last challenge was to have reconfigurable automatic assembly systems, where you one day would be able to assemble a certain type of component and then quickly could turn it over to do another type of components or another type of tasks the next day. Research activities then defined on the basis of these industrial challenges were the ones you see in the second column. Could be about delicate handling of deformable objects, real-time detection of such objects, part feeders, automated configuration of vision and sensor systems, or automatic design of a robot platform for industrial assembly. And these were, for instance, the titles of PhD projects, where the PhD students were then working on research activities, hopefully also resulting in input that could be then demonstrated in pilot projects at these 3 specific companies where the pictures are taken. And then, based on the general knowledge created, innovation conferences, open lab visits, industrial visits, but also demonstration projects for particular small and medium-sized companies were then conducted as a part of the MADE platform. Just to show you some of these projects here, you see 2 different products of the Danfoss company, who they wanted to be handled, assembled within the same assembly station. You see on the left-hand side the parties involved in that, and here you see a small video showing how the robot and the stations look like, and how you easily can reconfigure them. So the pilot project as such, you can argue, probably is not research, but in order to get to being able to make the pilot project run, quite a lot of research had to be done, and this was then performed in the PhD projects. So of course there is a delicate balance when you work with industrial relevant projects to always maintain focus on research content as well as the application. So this slide is in Danish. This is not this is, you can say, a free Danish course, but I didn't want to translate it. So along the line of this initiative, the granting body, the Danish Innovation Fund, made a midterm review, and what they did is they asked the company, so for the specific solutions that have been provided, what is the value that you see, or increase in productivity that you see directly from those activities? And that's circle number 1, and you see 90 million Danish kroner. So if you were then, they were asked to implement those results in parallel production systems, what would the value then be? And that's bullet number 2, so approximately double. And then, of course, the rest is speculation. But now let's see that other companies in the MADE platform would have similar challenges. So if those solutions would be implemented in the MADE companies, what would the benefit be? And there you see suddenly it goes quite big. And if we were to sort of forecast if all relevant Danish small and medium-sized as well as big companies would implement these types of solutions, what would the value creation then in fact be? So the Danish authorities, based on these types of analysis, and I admit you can always discuss the numbers, were quite happy with the investment, because the initial investment of the Innovation Fund was only, I would say, 64 million. So here you see again some numbers taken when the first project was quite mature, and the second project, the MADE Digital, was only in its infancy. And let's say from a societal point of view, the total investment in these two projects were around 120 million Danish kroner. So you don't need to be a big professor to understand that the payback is actually quite good from this investment. MADE platform uses a lot of channels to professionally communicate results, events, and so on. Made.dk would be the website. So if you are interested, I would urge you to go in. You can follow it if you are interested. The thing is that all the companies who are a part of MADE can follow these activities, can enter the conferences, can go for open lab visits and so forth for free. They pay a membership fee, and that would allow them to gain access to all of this. So 2 years ago, it was decided to go for a third round of funding. And every time, I guess it's the same in your country, you have to apply for funding, you have to come up with new ideas. And the new idea here was to focus more on sustainability and creation of talent. Challenges were, you can say, still the same, or even, let's say, challenges were intensified over the years. Quick response to changing markets, fluctuating supplies, increased pressure on sustainability, and of course the fact that the companies are actually short of good skilled people to do the production. And so many of the companies in Denmark struggled with the fact that how to actually go into this sustainability loop into circular economy, and also they struggled with what are the consequences for the way they organize themselves around that, from a product point of view, but also from a production point of view. So we used in the definition of this third initiative this technology development approach, and all the companies could agree on these three main topics, namely flexible and agile manufacturing systems, sustainability, and how to get talents. And that led then to a different model, because something needed to be new, of course, for the funding agency. Again, working from the very basic technology level to the business model level, but now on top of that, working on how to actually come up with the relevant competences for our workforce. Here you see a screenshot of who are participating in this project, and I think it is quite clear that complexity in terms of program or project management is quite high, and also how you sort of level expectations across all these players is quite a big effort. So there is a managing director of MADE, there is a secretariat who makes sure that all this happens, and this secretariat is not placed at any university but at the Danish Industry Association, DI. On the top right you see their logo, and this makes I think makes a big difference. So it's not the child of only one university, it's a child of the Danish Industry Association. And to give you some ideas about the numbers of this third round, here you see them in Danish kroner. If you need to translate, 7.5 Danish kroner corresponds to €1. So here we have a total budget around 300 million Danish kroner, of which 80 come from the granting body, the Innovation Fund Denmark. But you also see that industry actually pays a significant part of this party in terms of direct cash contribution, but also in-kind contributions. Then I'll share a few thoughts, examples of what has been made in under this platform here about process change for prototyping and pilot production based on additive manufacturing and injection molding. And so, of course, 3D printing. I'm not going to talk much to you about that. If you 3D print plastic components, you may have problems in getting the same material or mechanical properties of your parts as if you, for instance, injection mold them. So having a combination where you can quite quickly make mold inserts for injection molding and then injection mold was interesting. And of course, you can make metal additive manufacturing to make permanent molds. The idea here was to make polymer molds. We investigated this process chain. You will be able to find on the market companies who provide this service. But here the idea was to see how precise can we go and how can we work on the lifetime. So working with modular molds like this, where the green parts are the mold inserts, which are then 3D printed, as you see it here, fit into molds and then run with industrial machines in industrial settings with the industrial process parameters that you would look like. And of course, it gives you some challenges, because if you take a plastic mold, it doesn't have the same thermal or mechanical properties as metal molds. And that would, of course, influence the lifetime of the mold material. But as you see, some results were not too good. Some were better in terms of number of shots before failure. These are relatively old numbers. We have reached a couple of years ago 10,000 shots in polymer molds under basic injection molding conditions, and with those types of results, suddenly for industry, it becomes relevant to run pilot production with these types of methods. And the argumentation is, of course, that if you take an ordinary injection molding machine process, you have quite high initial investments. In additive manufacturing, your initial investments are not very big, but scalability is quite expensive. And therefore, in combining that to use additive for making tools that may not last so long as a metal mold could be interesting. We found that an ordinary milling scenario of molds or mold inserts, you can actually by using this cut your lead time at least by 1 or 2 weeks, which is interesting for many companies who want to have quite low lead times. And of course that affects the tooling costs, as you see it here. we found that you could actually reduce tooling costs by around 90% in these two cases. And here you see the batch size that was interesting in this investigation was 100. Also interesting is the lead time, and in particular a company like the Danish Lego company producing toys are interested in testing new ideas with a very low cycle time, so very high rate of repetition, and preferably in the materials that they also get when they do injection molding in an ordinary process, and therefore this is interesting. You can do break-even analysis. I don't know if that's so interesting. So this is the type of projects that were conducted together with companies. We looked into some direct 3D printing. That's the hearing aids you see on the left-hand side. The injection molding that I just showed you in the middle picture. And then we also conducted research together with the companies under the MADE platform in doing what we call freeform injection molding, which is a low-pressure injection molding process where we use a 3D printed polymer mold, which is then, after the injection molding, dissolved, because you cannot get the part out in any other ways. This, by the way, was also published in CIRP a couple of years ago. And so recently we then combined these efforts with computer vision and some kind of machine learning, or at least neural networks. And I'm not expecting you to understand in detail this graph, but showing that if you work with image processing of, for instance, pictures taken in an injection molding process, you would need to connect decision points with the pictures, and you would need to understand what is it I'm going to look for. And so we have conducted a research project where we equipped these types of injection molding machines with cameras. What you see here is one camera taking an ordinary picture, but also infrared cameras looking into temperature distribution, and then analyzing, looking at the pictures, both of the parts and the molds, in order to collect a lot of data and to understand how wear is progressing in these relatively soft tools by using advanced image recognition methods to, for instance, recognize where do we have flash, where do we have breakage and residual material. Training in this way databases of how these things look like, so that we are able to predict in advance a failure before it actually happens, and we can change the mold as it progresses. And this is research which has just been accepted for publication, also in the CIRP annals, for a presentation at the General Assembly this year in August. So with this, I'm coming to the end. So I have presented to you, let's say, the thoughts behind the way we have structured the Manufacturing Academy of Denmark, which is, in essence, a way to have industry and academia work together, but with a big focus on what are the industrial needs. I mentioned the complexity of the way that this type of program is organized. I've given you a few examples of some of the contents, which of course is always interesting. The network that was created in this aspect is very interesting at a national level, and has also led to many new collaborations. I don't think that MADE has gained an international sort of aspect yet. It may come. But with respect to the international network, of course, CIRP and the International Academy of Production Engineering is second to none. And here also we have the collaboration between academia and industry, but not so much driven by single or specific problems in industry, but let's say in a collaboration between the two.
Thank you very much, and we will go to the next speaker. Thank you so much.
Bye.
Bye.